Hi, my name is AJ Thacker. I'm a computer engineer here at Stevens.
Hi, I'm Juan Jimenez. I'm also a computer engineer here at Stevens.
My name is Thomas Essen. I'm also a computer engineer here at Stevens. And today we're bringing the Mithril system, which is a missile and ballistics detection system. So, recent war zones have shown the urgent need for missile defense. Missiles, long range projectiles, shelling are very prevalent in modern warfare and lead disastrous effects on the populace. So our proposed solution is a distributed missile defense system. So a low power phased array radar network that can detect high speed projectiles in real time, where edge computing occurs on each individual device that is then communicated and relayed over a distributed area.
The technical plan for our proposed solution includes first and foremost a PCB, which should include capabilities such as signal synthesis via something like a VCO, beamforming for the phased array aspect of the project via phase shifters, down conversion via heterodyning with an RF mixer so you can sample at low frequency, and then GPIO so that we can control the PCB via a microcontroller. So the microcontroller, again, it should be able to control the PCB and then retrieve the signals from the antennas on the PCB. And then we want to integrate an FFT onto the microcontroller so that we can detect when a signal has been returned so that we know when an object is in the sight of our beam, and then logic so that we can calculate the distance and an angle of that object that we detected. The distributed networking part will lie within an IoT or mesh networking framework. We will use some kind of communication protocol to send and receive data, like MQTT or TCP/IP. And then the nodes will be able to see what other nodes are seeing. So if an object is detected by one node, other nodes can steer their beam electronically to actively detect projectiles. And this is a visual representation of our plan, again with a microcontroller for controls and a PCB for the radar capabilities.
So as AJ was saying, our plans are really to implement this using ICs and eventually to have it printed on an actual physical PCB board. So our first milestones are around prototyping and testing out the ICs on protoboards. And we hope that by the end of our senior capstone project, we'll be able to have the full layout of the PCB printed and create the 4 nodes to implement our prototype missile defense design. So what's in our budget? What goes into the individual nodes of our system? Like AJ was saying, we have VCOs, phase shifters, amplifiers, SMA connectors. And after totaling up all of those costs, we have a projected cost of about $300 per node. So for the 4 nodes that we need for our fully built prototype system, that would be around $1,200, $1,400. That's what we're looking for in our terms of our budget. And what we're looking for in terms of L3Harris support, of course, is financial support to get the nodes working, to get all the ICs and the PCB printed. But mainly we're looking for technical expertise, especially any RF or PCB design experts at L3Harris who we could really use to bounce off ideas, make sure we're on the right path, and sort of validate our schematic designs for the PCBs, since we don't have a lot of experience with that. And thank you. We hope you'll be interested in our project, and thanks for listening to our presentation.
Thank you for listening.